Riverside Library and connecting up via Zoom. So we've got 10 people here down at the library, which is probably our best turnout since, well, forever, I think.
Great go.
Just trying to stop this squeaking at me, my own machine squeaking back. And currently we've got John on Bribey Islands connected on Zoom. We've got Alan, 4AAM, Kent, 4KWS, and Frank, 4FLR up in Rockhampton. And thanks very much for everybody to come in. What do we say? Thank you very much for participating tonight. We'll just do a little bit of the housekeeping. Last month we had the annual general meeting, and that's come and gone. There's not too much arising from that at this stage. Just after that meeting was run, as most will know, just trying to, that's better. No, it's still talking back at me.
Peter, could you mute?
Bear with me a second, guys. That's it. Yeah, that stopped it. It's really off-putting when your own speech comes back delayed. So just after the last meeting, Colin for UB and myself undertook our microwave road trip up to Rockhampton, and we were very successful. We managed to work a path that had never been done before, and in doing so, we've taken the Australian distance record for digital on that band at least. And we're going to present some photos and stuff of what we did as part of that. Now, it was done with aircraft enhancement, so we're going to talk a little bit about aircraft enhancement at microwave frequencies. And Cole's going to speak later on about the use of AirScout, which is one of the virtual radar systems, which makes aircraft scatter really possible and easy to do, because you can predict where the aircrafts are. I thought I had a bit of an understanding of what was involved in aircraft enhancement, but I was completely wrong. There's more magic there than I was aware of, and we'll touch on some of that as well. Just some practical stuff now, just to tell you as well that the Winter Field Day, remind everybody, is this coming weekend. There's a few portable and home stations will be on. I'm going to be going up to Howells Knob, and there'll be some home stations on, so just be aware that that's running. The next meeting of this group, in case I forget later on, is the 27th July, and that'll be a combined Zoom and face-to-face meeting here at the library. And the next actual microwave activity day is the 17th of July, so that's not that far away either. And just one other bit of news is, as we speak, Rex VK7MO is in Hawaii, and he and some Californian counterparts are trying to work that path from Hawaii to California on 10 gigs through ducts, and we'll see if they manage to do that. It's been done on 5.7 gigs, but it's never been done any higher than that. So he's currently there at the moment trying to do that. So keep an eye.
You've got to go up and down the mountain to find the level of the duct.
Yes. So now let's see. Screen share. I'm just going to call up the little PowerPoint presentation.
Could I just take a moment and say Roger apologises, he's snowed under with editing the next hour maybe.
Here we are. This should come up now, I'm hoping. There we go. Okay. So a little presentation on aircraft enhancement. So as I just said earlier on the 27th of May, we've taken back the digital distance record for the 9-centimetre band. After a bit of pre-planning over a few months. Oh, what's happened there?
Sorry, Michael.
Stand by, we'll get normal service will be resumed.
Trying to get picture in picture.
Bear with us.
Nothing to bring your face up.
I wouldn't, buddy. Not, certainly not needed.
Certainly. We know what he looks like.
Okay, so the contact that's taken the record is was a contact between myself, VK4UH portable up at Zilsey, at the QDH of Frank, VK4AFLR who's connected, down to Trevor, VK4AFL from his home station in Birkdale. And the distance for that was 524 kilometers. So that's the longest distance that's been done digitally, terrestrially at least, within Australia. So just to show you where that path is, for anybody who doesn't know, it's an entirely across land path, with the exception of the little bit at the Zilsey end, where we've actually got takeoff over the ocean. So the plan, what was this all about? Well, the reason to even try to make this attempt was that guys down in Brisbane have been using aircraft scatter and trough propagation on 144, 432 and 1296 megs for the last 2 years or so. And they gather there's something in the order of 500 successful contacts have been made up and down that path. And so it just seemed like right pickings if we could just go ahead and see if we could do this on the higher bands. So the plan was that Colin and I would undertake a road trip. We would drive up to the Rockhampton area, taking all the bands from 1296 up to 10 gigs and all the portable gear that we needed to do that, and try, if the propagation was there, to work back to Trevor and to anyone else at the Brisbane end who was available. And we made this coincide with last month's microwave activity day, so that we knew on the Sunday there should be a reasonable number of both home and portable stations out. And we would hope that we've been able to make some contacts with the team over longer distances. So the plan was that we would spend 5 days away, 2 of them for traveling, and that would give us 3 days of operating opportunities on the Friday, the Saturday, and the Sunday to try the easy paths first, and then if it was possible to extend them, or if it wasn't possible to keep trying until we got some results. So that's what we did. So we set off up there, drove up on the Thursday, had 3 days of operating, and drove back on the Monday. So the contact that we actually made used aircraft enhancement, which we'll talk about a little bit more. Just one more thing to say is that although the guys down here have been talking up to or being in contact with the guys in Rockhampton on an almost daily basis, for the 3 or 4 days before we left, they'd had no success at all. So there was no trace of any tropo enhancement whatsoever up along that path. And so, but we weren't sure it was going to work, but we decided we were going to do it anyway. And on the day, we actually spent 3 days. We only succeeded on the middle day, on the Saturday, over that path with aircraft enhancement. And we could identify the aircraft that we used. It was an Airbus A320, which was en route between Brisbane and Cairns. And it was at 40,000 feet traveling north, and just abeam Bundaberg at the time that we had the contact.
A320 is not all that big.
No, no. So this was done with a digital mode using which we'll talk about a little bit later on, Q65, which is the new go-to mode for digital on microwave, and using 15-second periods. Q65, if you're not familiar with it, is the latest digital DX mode within that suite from Joe Taylor, the WSJTX suite of programs. It's originally intended as an alternative to JT65 for Earth-Moon bounce work, but it has a lot of potential for a lot of other applications, and it's the go-to mode now, particularly with the short periods. And frequency we use 3398150. So the equipment that we used at my end, whoops, sorry, let's go back. The equipment at the Rockhampton or the Zilsey end was just my normal portable system. It's a 15-watt system. IC705 is the transverter, or as the IF transceiver, Coon transceiver, a Coon transverter, and a stealth PA. And the antenna that we took was a 1 meter parabolic dish, a mesh dish, which with a feed which would give us all the bands from 1296 up to 5.7. At Trevor's end back in Brisbane, he had 20 watts at the dish. TS240, I beg your pardon, there's a typo there. TS2000, Coon transverter, and a new PA that he just bought. And he also had a 1 meter parabolic dish, but his was 16 meters above ground level. Mine was on the deck, so it's just above the sea, as I'll show you in a minute. So the trip itself, as I said, we planned to travel up on the Thursday, give us 3 days of potential operating, and then travel back on the Monday morning. So to make that contact, we drove something in the order of 1,500 kilometers. We used 200 and something liters of diesel. We actually spent 10 hours of driving, 20 hours of driving in total. But we operated over those 3 days for probably another 19 hours to make the one contact. Was it worth it? Every bit.
Even just paying that to children.
Absolutely. So this was, we went up in my old patrol, which is, I think, almost as old as I am now. Made a few changes from my usual portable, now mounted the dish on the roof, which means you get a lot more space inside. And I put the fuel tank and the generator on the roof as well, so that we're not breathing two-stroke fuel for 1,500 kilometers like I normally would. And we were hosted by Frank, who you see here in his own shack. Frank put us up for 3 days, put up with us before, and was the best host that I can imagine. We all had a very good time, actually. And I think we've left behind some interest at the Rockhampton end to do some permanent microwave work up there. Apart from 1296, there doesn't actually seem to be too much microwave activity anywhere much above the Sunshine Coast. So on the first day, we drove to the top of Mount Archer, which is the highest point overlooking Rockhampton City. This, we thought, height is might, so the higher up we could go, the better off it would be. So we set up on the 3.4 and we ran all day, and we got nothing. Absolutely not a trace of Trevor at the other end. This is just some photos of the dish set up. So obviously doing aircraft scatter, you've got to point the dish in one place. You've got to know where you're pointing because you only get one chance. There's no opportunity to do any peeking or tweaking. You've got to you have one shot and that's either correct or it's not. So in azimuth and elevation. It's just a little look from what we could see from the top of Mount Archer. It's a beautiful lookout.
Apparently there's a lot of RF up there too.
There is, luckily not too much as high as now. Where my finger is pointing is the direction back to Brisbane. And it's pretty flat except for that one little peak that you can see there. There's a bit of a story about that peak at the end of my finger. Anyway, after having failed for hour after hour, Cole said, "You better come and see this." And what he found was this is the path using AirScout between our two locations, me portable up on Mount Archer and Trevor's location. I don't know how many people are familiar with AirScout, but basically AirScout is a system. It uses virtual radar data from known aircrafts and plots where they're going to be and advises you which are the ones that are likely to be usable for aircraft enhancement. So I'm at this end here on the left-hand side of the trace. Trevor's down here at the right-hand side. The red line, this is basically all the sky that I can see jumping over any intervening peaks and troughs in the local terrain. And the yellow line is what Trevor can see. Where those lines cross gives you this little purple triangle. Now that's the area of co-visibility. So any aircrafts that fly in there, we'll both be able to see and therefore are available for contacts. What I can tell you is that that purple area on this path is incredibly small. That's very, very tiny. So this is what Carl was trying to show me. So the opportunities, the opportunities to have an aircraft in that spot, this is why we're not succeeding. We're in the wrong place.
And the horizon, the red line or the yellow line, question, is it really accurately forecast, with some angle due to the terrain, 3 kilometres?
So we use globe data and gives you that.
I'll let Cole answer that in his bit of the talk, because what he'll tell you is that when the planes shine up in this purple area, it's going to work. This is the comparison graph from Frank's location in Zilzi, which is actually lower down, right at sea level. But look at the comparative size of this purple area here. So we decided we would stop on the Friday, and on Saturday we would set up exactly in the path that we know that works. We'll try this again from Zilzi.
So that first graph was from Mount Archer.
From Mount Archer. So this is Frank's deck up in Zilzi, and it's right down at sea level, overlooking the ocean. But the big difference is that you're looking over the ocean, so there is no close-in terrain at all. That's Cole's umbrella dish. And this is the 1 meter dish that we took up with us with a multi-band feed on it. So set up on his deck, so only a couple of meters above ground level. That's the view that it gets. So it's really just looking straight out over the ocean. So here's the gear setup. So 4 transverters. The top one is a little 30 watt 1296 system, 15 watts available on 5.7. The big box in the middle is 2.4, and the 3.4 gigs stuff is at the bottom with about 15 watts or so with the stealth PA.
Can I just say something, Jerry? That 35 watt system on 1296 with that 1 meter dish was more than adequate to work for AMG on aircraft scatter on 1296 or so.
I'll come to that, but this is compared to what the guys are running. I mean, Frank there has a very large Yagi array and a 500 plus watt PA, and that little system is 15 or 20 watts in a 1 meter dish. The 1 meter dish doesn't have all that much gain at 1296 really, so it's pretty small potatoes. So we sat there and we operated, and the beauty of Q65 is that you just let it run. Every 15-second swap overs, you just let it transmit back and forth, and you wait for the aircrafts to come into the path. You use AirScout as their virtual radar to give you some warning that they're coming, but you just basically keep on going until you either run out of steam or you have contacts.
That's a lot of 15-second windows.
It is.
All day.
But it worked. We used Q65 mode. As I say, this is the latest go-to mode. It's got a lot of advantages over the previous software programs that we've run. And Q65 allows you a number of different variants where you can go sub-modes A, B, C, D, and E and different time periods. And as you change the combinations, it changes both the time period and the tone splitting. So there are certain optimum combinations for aircraft scatter on some bands compared to EME on other bands. And Q65 15B is the one that everybody seems to be getting the best success with. And here's the proof of the pudding. This is the received screen at Trevor's end. Always the destination call sign is always the first one in all these digital modes. So this is what Trevor's received. He's seen me calling CQ, in the first ring. Second, he's given me a report. I've given him an R report, and that's dB above the noise. And then there's a 73. So once the aircraft came through, the contact is complete within 4 or 5 exchanges at best. So that only took a few minutes to do. I took a screenshot to prove the same thing from the other end. It's live off the screen. Yeah, you could. The best receiving, and you can't see too clearly, there's -13, but the signals did come up, and I'll show you a bit of video at the end where these are actually audible in the speaker. And probably could have been done on SSB if you're really quick enough. If you're on your toes, you could have done it. So we only did it once. We tried to repeat the experiment on the Sunday and failed. We didn't succeed, but what we did succeed, we thought, well, if this is working, we'll try the dish on 1296. And managed to work Trevor on 1296. This little trace here is the signal that's coming in the waterfall. That's actually very widely spread, so that it shows that there's a lot of corruption and Doppler on the signal. But again, it's totally successful on 1296. We also managed to work, oh, sorry, there's the digital stuff coming back in. We also managed to work George for AMG with that same system. And, you know, we're getting signals at -9. That's certainly loud enough to be heard in the loudspeaker, and it's loud enough for SSD. So just talk a little bit about aircraft enhancement. As I said, it's something I thought I had a handle on. But aircraft enhancement has actually got 2 components in. It's got 2 components and some magic. So some parts of the using aircrafts to propagate signals is due to reflection in the classic sense, like light shining off a mirror. But some of it is due to scatter, because the aircraft is blocking the wave fronts coming between the others. It actually can focus your beam, your signals in the same way that a Yagi focuses signals. And there's a very special phenomenon called forward scatter enhancement. And this is a phenomenon that occurs when the aircraft are exactly midway between the 2 stations. I'm not going to go into too much of the physics of it. There's a lecture in itself just in there. But when this actually occurs, you can get up to 30 dB of gain, of enhancement, for a very short period of time. So flying aircrafts are more like flying Yagis than they are flying mirrors. But in the same way, as a Yagi, you get more and more gain as you go up in frequency. Aircraft enhancement, forward scatter enhancement is increased as you go up in frequency, but so does the narrowness of the beam that it's enhancing by the same effect. So it doesn't last for very long. Now, it's rather akin to radar, and we're sort of normally think about radar as the system on the left-hand side. That's what you normally use for radar if you're looking at aircrafts or ship. A single site transmits a signal which is reflected off the aircraft fuselage and received back at the same location. But there was a much earlier system that was in use long before monostatic radar, and this is this bistatic radar, which is more akin to what we do, where the transmitter and the receiver are actually in different places, and the reflected energy comes back from one side to the other. Now, it wasn't until the 1930s that it was realized that aircraft could actually affect radio waves at all. But anybody who's ever had an old VHF TV or listens even on 2 meters knows the effect of an aeroplane flying over the top of you, where you get this rapid fluttering signal because of periods where the signals, the reflected and the direct signal are enhancing and then cancelling. And what you're actually hearing is the Doppler effect of a moving airplane. This is actually an aviation beacon. It's a VOR, which is actually a constant carrier with some sidebands on. This is a waterfall display, and the orange line down the middle is the direct signal. And aircraft are, because they're flying and creating Doppler, they're producing lots and lots of versions of the same signal. So that's just to show that aircraft do reflect signals when they're close in and overhead. But what we're talking about, of course, is using the reflections or the refracted signal when the direct signal is not there. So just to fill in the things that you want out of aircraft enhancement, what you're looking for, from the aircrafts themselves, the larger the aircraft, the better, or the larger reflecting area, the better. And certainly metal aeroplanes are much better for aircraft enhancement than the Tupperware ones are. The new composite aircrafts made out of carbon fiber, and they have a much smaller reflecting area. And of course, the stealth bombers are designed specifically so you can't see them on radar at all by making them basically invisible and not refracting or reflecting anything. So big airplanes you're looking for. The altitude of the planes is the next important thing. The higher they are, the better, because that means you can see them from further and further away. Most commercial airliners run out of go at about 40,000 feet. There's very little commercial traffic above that, since we don't have any Concords anymore. So the higher the altitude, the better. And the terrain.
What about flying level versus climbing off?
I think we'll come to that. The terrain that's underneath you is important as well. In fact, it's important if you've got hills and things blocking your co-visibility close into you. That's what limits the size of that purple patch. The higher the planes are in that purple patch, the longer time you've got for communication. Whether they're going up or down doesn't seem to have as much effect as you might think. And the real enhancement occurs from what we've talked about earlier on, the forward scatter. You get the best enhancement when the planes are in the exactly halfway between the two stations. There's that added boost of somewhere between 10 and 30 dB of extra gain when the plane is just in that sweet spot halfway between the two of you. So you want big airplanes as high as possible, not too much terrain in your way, and aircrafts to be at the midpoint. And the orientation of the path. So the best situation of all is where the two planes or the plane is flying along a path that connects the two stations together. And when it's at the midpoint of that, that's the sweetest spot of all. Failing that, if the planes are flying parallel to that track, that's the best. And the worst situation is where the planes fly perpendicular across the path, because in that situation you get the worst of the Doppler, and the time available for communications is the shortest, and you don't get the Yagi effect pointing along the path. So the super best parallel or along the path between the two stations. And as I said, you can get 10 to 30 dB of enhancement if you've got all those ducks in a row. And this is why the software program that Carl's going to speak about warns you when this is going to happen. So the aircrafts are more like flying Yagis, not mirrors, but you've got to have the Yagi pointing in the right direction. So the plane coming straight towards you, straight away from you is really what you want.
By Yagi, I'm hearing parasitic elements and stuff like that.
And it's actually the same effect. It's the blocking of the wavefront and redirecting it around the front of the aircraft that generates the sharp lobe out of the front of the aircraft, just in the same way that a Yagi creates its gain. So when you're using it, aircraft enhancement can give you distances out to about 900 kilometers. Aircrafts at 40,000 feet, just from the pure geometry, you can see those out to about 400 kilometers from either end if you've got clear terrain. So that gives you the potential to work twice that. So you're up at about 900 kilometers. And if there's any other sort of tropospheric enhancement at the same time, you can go beyond that, but still relying on aircraft enhancement in the middle. It works everything from VHF right up to the higher microwave bands. Aeroplanes are right there just about all seasons of the year. And the signal strengths that you get back can be very high indeed. It's certainly loud enough to hear in the loudspeaker, unlike ENE, for example. We talked about virtual radar that Carl will speak about, AirScout, and there are other programs that can be used as well. They can be used to predict the viable paths. You can actually look at, you could say a path between here and anywhere else you like, and look for the previous 24, 36 hours and see how many aircrafts come down those corridors. It gives you real-time positioning of the aircrafts in the here and now, so you know when aircrafts are approaching, and it'll tell you when the path is likely to open. The way it works is that it shines up lights up little aircrafts for you on the path in different colors to tell you whether they're at the right height and give you an idea when they're going to intersect with that midpoint, and all the other characteristics that you're looking for are going to be matched.
So
and that
set it up for one path and then stay on.
Yeah, absolutely right.
But in AirScout, you can have multiple paths. You can have, yeah, you can watch up to 30 different paths if you want to.
Is it feasible to transmit to one plane, bounce off that onto a second plane?
Yeah,
well,
of course.
Presumably it is, but the opportunities are going to be pretty small to do that. So let's just see if the audio will come across. I took 2 little bits of video here. Let's see if it plays through the speakers. No, we haven't got any sound on. So that's the end of my bit. Cole's going to speak shortly on show you some AirScout stuff. But are there any questions from anybody either in the room here or anybody coming in on Zoom? If you want to unmute your mics at this stage, we should be able to hear you. Any questions from within the room here at all?
Kevin, I'd just like to thank you and Cole and Frank and AFL, Trevor, for your efforts on that weekend, because I had a really great time. And I think a round of applause for the four of you. It's two of you doing all the driving, but the four of you for your great effort for that particular weekend.
Thanks, John.
Okay, I'll go back to sleep now.
Yeah.
Who was that? Was it George?
We can see you, George. You appeared on the screen.
Only briefly, mate. G'day.
Hi,
G'day, George.
How are you all?
Good. We're all good. All right. So Cole's going to come online now, and he's going to share his screen and put up some AirScout stuff and talk you through that.
Hey, Andre.
I'd have a couple of comments about it too later or whenever.
Okay. Well, give us now. Let's hear.
Yeah, go for it.
Tell
Yeah,
us.
speak up.
I speak.
You're talking to that thing on the seat.
A couple of things regarding aircraft enhancement. As the name suggests, it enhances an existing situation. Doesn't create a new contact so much out of nothing. Another question that is sometimes asked, would it be better to point the antenna at the aircraft? And that's definitely not the case. About 20 years ago, I was, in fact, my introduction to aircraft enhanced signals were stations south of Brisbane on 432. And at that stage, the array that I had was capable of being elevated. So a few times I elevated the antenna, pointed it at the aircraft, and there was absolutely nothing. So the aircraft was enhancing the direct path signal, which would have been there all the time, but just too weak. But so that's one thing about that. And you can further prove that by the fact that these contacts are not always repeatable. And in the case of the contact to Rockhampton, there was one excellent shot, so where obviously everything lined up. Now, you would think that perhaps the same aircraft on the same heading at the same height, with everything the same at both ends, you should be able to, in theory, repeat that, but you can't. And we didn't certainly on that day, and I never have on numerous other occasions. So yeah, I think that's about the comments that I would have about aircraft enhancement.
Yeah, okay. Thanks, Trevor. Yeah, there are a lot of features that there was obviously one piece missing out of the jigsaw puzzle, because there's a lot more aircrafts up there, and yet not all of them enhanced. And I'm coming to the thoughts that it's that forward scatter enhancement. If you had enough power at either end, you could get through with just pure reflections. But in the situation that when we rely on that little burst of extra magic just when the aircraft is coming along the direct path and is exactly halfway to make the contacts possible. And they don't have to be far off before it doesn't work anymore. So, but there's a lot of aircrafts up there. If you're patient enough to wait for one and you picked your path properly and predicted it, it's going to work.
Well, the VK2s use it just about every day.
Yep.
And regularly too. They just on 70 centimetres from what's his name there with the pub, does the harvesting, Mark at Kempsey. No, he just shoots across the Kempsey, but he's Mark. I can't think of his name right now. VK2 gets on 6 and 2 and 70.
I know who you mean.
Hey?
I know who you mean.
Yeah. Yeah, he works across to Kempsey and across to a few of the other guys on the coast, like Daryl, or 2 BLS, and regularly on, and they just use aircraft.
So you think that's because there's increased aircraft between Sydney and Brisbane and
I don't know. Yeah. Well, I know 2XN and myself constantly can have a contact on 2 meters using Q65, and when the Brisbane to Adelaide flight is at Ashford, which is the sweet spot, he goes from sort of -21 to -10 dB. So it works. There's no denying it or questioning it. It just works. But anyway, that's what I've found in my bit of mucking around. And Rex on Fuel's got in David 3HZ. I've got a magnificent paper out on it, on forward scatter and how it all works and the stuff they've done on 10 and 24 gigs. And as you know,
right angle crossing.
Right angle crossing. Well, we did that 10 gig, 800 Ks almost on a right angle cross from Cameroon Lookout to Sapphire in central Queensland. And that was a flight coming out of Auckland to Shanghai. Yeah. And it was traveling across the path, and that AirScout picked that up as that plane was coming across, and we looked at it with a big plane, said red, and it was sitting at 40,000 feet, and we just waited to 25 minutes, and away it went. And with AirScout, what a lot of people get confused with is, oh, I can't see any planes, no planes. Well, what it is, it's your circle setting of how big an area you're looking for. You don't want to be looking at 10,000 kilometres in a plane over Adelaide, because it's totally irrelevant. What you want to look at is a 100-kilometre radius. And that'll only show the planes that are going to be in that area. And that's it. But if you want to look at it, AirScout, it tells you down the bottom how many aircraft it's updated. And then you can be looking at 64 positions have been updated, but you'll see 3 planes. Because the only 3 that are relevant are on the screen. And that's where a lot of people get disenchanted with it. And there's also several different types of terrain data to use. There's the globe, which gives you the nice little down the bottom. Then there's the new Aster one, which is 1 and 2. It's broken down into, I think, one's 30 square metres, one's 90 square metres of terrain data. So it can get very accurate. But the globe data is much easiest one for most people to use. And it seems to be accurate. It works for us. It's worked every time. And with Frank in the morning, I've actually got a position logged into AirScout that I'm at Trevor's place. And look at Frank's, and straight away, bang. Then I change it to George's location, and that same flight doesn't light up. And George can't get through yet, Trevor can, because Trevor's just that little bit further over, and the flights are actually flying parallel. And you can sit there and watch it all.
Got it, Colin?
Yes, George. So yeah, it works. It's pretty easy to use. It is, you don't have to use it all the time, but it's there. It's a tool. The higher in frequency you go, the bigger the reflector, the better chance. Like 24 gigs would be the next one to try. I reckon that'd be great. Oh, you've got a screenshot there, Kevin.
I'm trying to get it up for you now while you're talking.
Yeah, and what we found at Mount Archer was because we were like that, the aperture changed. So our squash it down when we were down lower, the aperture became greater. So, and co-visibility, like if you don't have internet access, co-visibility, like Gary, I know you've got an ADB receiver and you can see aircraft out like 400K, 350K.
250 nautical miles sometimes.
Yeah, you know, like that's a fair way out. Now, base stations can see that. You can see that plane on ADSB on, what is it, 1090 megs.
1090.
You know, you both are going to see it. So that's a pretty effective reflector.
That's what I can't do with this.
But then, I find it useful. I use it all the time. I don't have a problem with it. Some people think it's nonsense. I think it's all nonsense. Oh, it works. It's simple. Yeah, a lot of people, like I said, people get disenchanted. I can't see planes. Well, yeah, if you want to, there's a max circle parameter you can set in there. Change it to 5,000. You see all the things you want, but none of them are going to be any good to you unless they turn pink. And what it gives you, as they're climbing, it'll tell you their climb rate and everything. As because you're just getting 80 speed up. And it'll give you an indication that it's tracking the right way. And between Trevor and Frank, I think it's about 315 degrees. I think they track for these guys. And if it's climbing up, and it's got to be northbound, because southbound they start dropping a gimpy and they fall out of the zone.
So here's a live screenshot now of AirScout running. So this is right now. This is the path between my QTH and Frank's QTH up in Zilsey. So where's my pointer? Frank's up here. I'm down there. You see this red, the aircraft's lighting up in red. These are ones that are likely to make aircraft enhancement possible. So that's flight QFA 1079. It's a Boeing 737. That's a sort of a small jet airliner.
It's 2.5 kilometres above what would be considered to be a decent reflection, but you'll find that it's actually dropping, and as it gets closer, it'll drop. So anything for the northbound and northern stations, you want the northbound planes.
Yeah.
Because as soon as they hit Gympie, Maryborough, they come and they drop out.
So here's the red line again. So that's my visibility from home. And here's Frank's visibility in yellow. They cross over at that midpoint, the sweet spot, which is shown by this cross here and the blue circle. All this purple area is the sweet spot. So aircrafts in that zone are going to be opportunities to reflect signals. Here's an aircraft, but it's close to the track, but it's too low because it's underneath. Frank can see it, but I can't.
If you look down the bottom there next to see 38 positions updated from the web feed to your left, see 38 positions were updated. You can't see 38 planes on that screen.
No.
One thing you said, Kevin, which may confuse people, is the sweet spot is in the middle of the path.
Yeah.
As you just explained with the purple area, any aircraft in that is in the sweet spot.
Well,
and some of my recent successes have been with aircraft as far north as Miriambar.
Yeah. Now, you've got far more experience at this as me, but you don't get that super burst of enhancement except at the very middle. So, I mean, if you had enough power at either end, any aircraft that's anywhere in that purple zone would do. But when it's in the middle, then you get the extra somewhere 10 to 30 dB of gain and makes the impossible possible just for a short period of time. So maybe I'm using the wrong terms. That's the best area when the aircrafts are here.
Yeah, well, you've done the reading on that, and I'll accept that. But and typically, I've seen 12 to 15 dB of improvement. I've never seen very much more than that. And Frank and Trevor's experience looks for aircraft that about that blue spot, which is just north of Bundaberg, and that seems to be the most reliable. I don't think I haven't focused on what the enhancement, the level of the enhancement, and as you identified before, and this is all part of Trevor and Frank's note taking, is there tropospheric assistance there, or are you just waiting for that aircraft to hit the enhanced spot, and that's the only few minutes of a contact you're going to get?
Well, I guess there's going to be times when there is tropo. I mean, if there's sufficient tropo, you don't need the aircrafts at all. So the other extreme where you're only doing it off the aircraft and all points in between. The enhancement from my reading, and it is just reading, it's not experience yet, does go up as the frequency goes up and the wavelength gets shorter. So by the time you're up to 5.7, 3.4, and then 10 gigs and probably above, the enhancement gets greater and greater in the same way that a Yagi gets more and more gain. but it has to be pointed in the right direction so that the opportunity gets much shorter in terms of time. But it's all untried territory. I mean, but it's another mode of propagation that we can all be using. So it goes on through the winter. It's something that we can all be having a go at, aided by AirScout and stations at either end. We can be having long distance contacts at times of the year and when we thought it wasn't possible and we should just be in the workshop building stuff. So I guess the whole benefit that Colin and I have got from this experience has been that it is possible to do these things, and it's just opportunities to take advantage of. Have you got anything that you'd like to say, Frank? You'll have to unmute your microphone, and we can hear you. We can hear you. No, I'm not hearing anything at the moment. So anyway, thanks very much for listening. It was a very interesting experience, and I think it'll be just a stepping stone to longer and longer paths. I mean, this was 500 kilometers. We can certainly be doing longer distances than that. As long as there's aircraft flying up and down between the two places we pick, we can be working greater distances and on higher and higher bands. So it's another food for thought.
Kevin, one thing this is bringing home to me is that the playing around, I call it, that we used to do 20, 25 years ago between Brisbane and Sydney. You know, I remember being out on field day and working Lyle 2BE and Gordon 2ZAB on 1296, local contact, just when the plane in the right position. But it was all happenstance, with all serendipity. But what you've revealed here is getting a handle on knowing when it's going to happen.
Yeah, yeah. I've been reading about what goes on in Europe, where they have 30 countries within this sort of distance, and incredibly busy and coordinated air traffic. They can actually work from the UK into places in Eastern Europe almost continuously, because there's almost always an aircraft at the right height somewhere along that path. And sometimes there are multiple aircraft all reflecting at the same time. We don't quite have that advantage, but we can still be using this. We could, this is another tool in our toolbox to be going out and using and making really successful and valuable contacts on the higher bands.
There's also another program called rainscatter.com. Have you come across that yet? Well, if you get a chance, just have a look at it. It's rainscatter.com. And it's actually grabbing, the guys in the States use it all the time for the microwave contacts. They get the weather data from the Doppler radars and plots of storms, and they go, oh, what's this one going to do? And it through rainscatter, 10 gigs all the time. They constantly posting it. They're like, storm. They drive out, set the dish up, 550 Ks, rainscatter, and they're just using the information from the Doppler from the weather. And if we could get that information to feed in, if we could get
that. Is that about local information available in this country?
In the States, it is. Yeah. No, well, I can't write an email. I'm not articulate enough to ask the bomb.
You got to be nice to people.
Yeah, I know I'm not nice, but you got to ask the bomb whether they can, you can get the data and feed it into this.
Maybe that's a worthwhile subject too, Kevin, that Frank has lived with the Met information since he was a trainee with civil aviation, and he wasn't successful in unmuting his audio there before, but he has phenomenal resources or access to resources that are online, the knowledge to access those resources and to show the other factors that may be involved in a particular path and particular contacts. So it might be worthwhile trying to rope him in for that part of the equation sometime.
I mean, I think that's a great idea. There's a lot of knowledge out there. Certainly, I'm quite spurred on, and I'd like to try this path again with some higher bands and some longer distances too. So the yeah, it's opened my eyes a little bit, and I think aircraft enhancement is probably one of the least appreciated modes of propagation at our disposal, and one that we're most underusing. All right. Is there any comments from anybody, either in the room here or through Zoom? If you want to join in, you've just got to unmute your microphones, of course. Otherwise, I'll thank you all for joining in. Yeah.
Have you actually got calibrated data about the difference between an A319 and a 737 and a
Yes.
777?
There is information out there.
On F100 Fox.
There is information out there. The aircrafts are being categorized, and there's a comparative number that you can get, which they call the reflecting index, or the
Rex paper.
Yeah, there's a paper out there which categorizes that a 747 is 35 and a Cessna 150 is 1 and a stealth bomber 0 and all the other steps in between. But the general principle is the bigger metal aeroplanes, the better. You know, the really big ones, the 747s, there's very few of them flying anymore. And the big international ones now are often composite, so they're not as good because they don't have as big a refracting areas, because there's not as much metal, but they are
quite a lot of traffic with A380s in this, between Asia and Sydney and Melbourne. But we in Brisbane only get one a day. And
although we don't know it, this program does, and it gives you a different size little model airplane to tell you how big the aircrafts are. You see some of them are bigger than others. That one there, for example, is what's that? So it's not helping. But the majority of aircraft flying up and down this eastern seaboard at the moment are the 737 size, except for some big commercial heavy freight traffic. But the program will actually sort all this out from you. All this is coming from ADSB data being collected and thrown up via the internet, but you can use your own receiver and you can at least see the aircrafts that are there in real time as well.
A good cross-check on aircraft and their heights is Flight Radar 24/7. I find that useful, and also go into the airline departure tables and preempt before they even get off the ground. So then you can see and do your initial tracking on a flight radar, and then come across to AirScout for the actual part.
Yes, and I think that's very true, George. That's a good point. But the bottom
comment in.
And this AirScout tells you they're in that purple zone. They're in that zone, and they go to work.
May I chuck a comment in, please?
Of course.
There's two people in the room. Cole probably did it as well. Going back about 6 or 7 years ago, we're using aircraft enhancement to the south. And the scenario that you were describing with the centre point being the cross was prevalent then down to Sydney, etc. Mick and Ronnie Crow are well aware of that. Also, I have noticed with my experience with 1296 with Frank, there's a little bit of atmospherics in play more so than the plane. I think Cole might remember us going to Pomona, and we're using 1296 coming back to Brisbane with a Yagi. And at first stop in the morning, when it was quite frosty, we'll say, there was no contact. But later on, during the course of the day, there was absolute unbelievable contact on 1296. So, which was atmospherics, not necessarily. We weren't using in those days. We weren't using this program, but this program's brilliant. Anyway, I just thought I'd throw that in for you because we used to use AirScout going south and there was a difference in the atmospherics reference to the plane, etc., than there is going north. And I think AFL Trevor should be able to put some more light on that, I would have thought, because my contact this morning with Frank was way before it was around between myself and Maryborough, or maybe Bundaberg, nowhere near the sweet spot of the cross. So I'm only new to that part of it, going that to the north, so I don't know enough about it, but it definitely has something to do with both, as well as with atmospherics. Whether it's tropo or not, I don't know. Anyway, I'll get up again and go back to sleep.
What I've done here, I've just flicked up on the screen the path from Brisbane down to 2MAX. So this is a southerly path. And you can see that there's a lot more aircraft. There's a nice big red aircraft here. Red means that it's a large red aircraft, and it's going to cross over the path. I'll just light it up for you. You can see the data. So it's actually an Airbus A330, a Tupperware airplane, but still a big aircraft, and it's going to cross over the path in 1 minute and 50 seconds.
No, it's 3 minutes.
Where do you see 3 minutes?
Oh,
yes, yes, that's right. Whether it's still going to be in the purple zone when it gets there, because if the aircrafts change height or direction, then they still might not come across. But
there is an option in AirScout also that you turn tracking on, and it can control the rotator.
Oh, yeah,
and two little dials come up, and it gives you ASL, and it can control the rotator. And it's also even got cat control for the radiator, the Doppler.
We did think about calling up the aircraft and telling them to divert to a different area. They were too far off. Anyway, this is live. This is actually coming off the internet now. So if you're at home, you can have this data up on your screen.
I was just thinking how incredibly amazing it is, all the data, number crunching that's going on there, and producing a graphical form of output. It's no mean feat.
No, it's the software is constantly being updated. Like at the moment, Kevin's using 1.3. There's 1.4 there, but it's still in beta, and it's got a few different functions, but it's the same.
Yeah.
It's just working on numbers, and like, you know, it's going. There's another one that W3SZ, I think he runs that Nighthawk website where Rex Moncure and Dave's paper is. There's a link to it from there. He done another talk on aircraft at some big microwave meeting recently, 2019.
Just to show you now, that red aircraft has turned purple. Sorry, Carl. Yeah. And it's what that means is it's now in the sweet spot. Yeah. It's not too far away from the midpoint. So if we were at home and aiming down at 2MAX, we'd be having a contact now. Yeah. Whether it's on 2 meters or 10 gigs, it'd be getting through by now.
When a few years back, when I was doing 2 meters from Belmont, AirScout showed me, you know, you see the profile down the bottom of the hill and everything. Well, from my location, I was firing straight into Mount Petrie. You know, and the only contacts I was getting to the south was with aircraft enhancement. You know, or midsummer tropo. You know, but aircraft was really necessary.
Well, with that Q65 mode, the other evening I was just on 2 meters on Whisper, and 5PJ and 5GF copied me on Whisper. You know, that's 1618 Ks. And anyway, PJ was there, and I said, let's try Q65 contact. And yeah, I had a Q65 contact on 2 meters. Yeah, we changed it to 60C.
It was chopper.
Must be. Well, inland. Well, Hepburn indicated there was purple and a little bit of blue, so it was marginal. But yeah, it worked like a train.
Kevin, just a minute ago, the colour of the the box changed from purple to brown.
Yeah, because it dropped us down to minus kilometre below.
He's down here. You can see the reason it's here. That aircraft is now below the point.
If you click on that, it'll light up what flight that is.
Yeah, I'll try and do that.
Yeah, it's moving. See, so there's QFA 632,
Which is
just
this,
below.
which is this one up here that we're looking at. So it's gone orange because it's too low. And although I can see it from home, I'd be able to see it from home. 2MAX can't. It's underneath his minimum altitude profile. Even though it's in the middle of the track, it's just too low. But all this information is out there for us to use, and it's live. It's just down to make.
300 watts.
All right. Well, I think. Thanks everybody for listening. It was a very interesting experience. And thanks again to the guys at the Rockhampton and Frank and
Thanks, Frank, for the hospitality.
Absolutely. We had a wonderful time while we were up there. It was good fun, and let's hope we can do some more paths in the future and even longer distances and higher frequencies.
We should take a 24 gig system up there.
Yep.
And then from Frank's deck, because it's actually a marvellous spot. Yeah. I made myself right at home. This clothesline, does it fold down? Folded the clothesline down. There we go. Moved chairs around, set a table up. It was beautiful. And then the next day we put ourselves in undercover out of the sun. It was even better. So he's got a nice spot there on that deck.
Yes. All right. Well, thanks everybody for joining in. It's one of the best turnouts we've had for a while, and we look forward to seeing you on the field day on the weekend if you're on, or in a month's time. Okay, good night, everyone.
Thank you. Good night, and thank you.